Good afternoon. Let's look at the next method of depreciation. This is an accelerated method called the sum of years digit method. This method is an arithmetic method in which we calculate more depreciation in the initial life of the asset and gradually taper off the depreciation expense. This makes more sense as far as the matching principle is concerned because we're going to match more expenses early in life when there is more revenues being generated by the asset. So let's take a look at the example we have over here on hand. Lockhart Company purchased a machine on Jan 1st, 2017 for $80,000. The machine has an estimated salvage value of $8,000 after a useful life of 8 years. In Part A, we are asked to calculate the depreciation for 2017 using the sum of years digit method. We'll calculate it for all 8 years. So let's start out by pulling out the relevant information. The first piece is the acquisition date. The acquisition date is Jan 1st, 2017. The second is the original cost of the asset. It's $8,000. The estimated salvage value is $8,000. The original cost is $80,000. The salvage value is $8,000. The difference between the two is going to be our depreciation base. This is the amount that we need to depreciate over the next 8 years. The next piece of information I need is the life of the asset. We estimate that it's going to be useful for the next 8 years. So in this particular method, I need to calculate a fraction, and I'll tell you what the fraction is and how we set that up. So let's start out with writing out what years we have. The years we have are from 2017 through 24, that's the 8 years. The depreciation base, we've already decided, is going to be $72,000. To calculate the fraction, we're going to add the sum of years. So it's in 8-year life. So we are looking at 1 plus 2 plus 3 plus 4. So let me write that out over here. If I had to calculate that, if I had to write out all of that, what it would look like. Let me redo this here. It would be 1 plus 2 plus 3 plus 4 all the way to plus 8. Okay, so Excel is thinking I have a formula over here. I do not have a formula. I'm just writing this out as text. I'd have to add up all the numbers over here. Now, if it's a number such as 8, we can still add the numbers up. But perhaps it'll be a better idea for us to take a note of an easier way to do this calculation. So using an arithmetic method, we can calculate those numbers as n times n plus 1 divided by 2, n being the life of the asset. So in this case, we're looking at 8 times 9 divided by 2. You'll get 76. If you add up these numbers, 1, 2, 3, 4, 5, 6, 7, 8, you will get 36, the same answer. Now this is the denominator in the fraction. So what's the numerator in the fraction? At the start of the first year, what's the remaining life of the asset? We have the 8 full years remaining. So the fraction I'm going to go with is 8 over 36. At the start of the second year, what's the remaining life of my asset? I have 7 years remaining. So the fraction is going to be 7 over 36. At the start of the third year, the life is 6 years. Remaining life is 6 years. All the way down to when you get to the very last year, at the start of the year 2024, I have 1 year life remaining, so it's going to be 1 divided by 36. So we can just fill up all of these numbers over here. So it starts with 8 over 36 and ends with 1 over 36. The fraction 8 over 36 is larger than the next fraction, and it goes down. 1 over 36 is the smallest fraction. The base is the same, the depreciation base, which means my depreciation expense is going to keep dropping. So the depreciation expense is calculated as the depreciation base multiplied by the relevant fraction. That'll give me the depreciation expense. So 72,000 times 8 over 36 gives me 16,000. 72,000 times 7 over 36 is going to give me 14,000. Do the calculations all the way through to get your depreciation expenses for all the years. In this particular example, it works out very neatly. It's 16, 14, 12. Doesn't always happen this way, but it's worked out well for us over here. Now add up all the depreciations and see what we come up with, 72,000. It has to be, because that's the amount I was depreciating. So as you can see in this method, it's an accelerated method, which means I have more depreciation up front, I charge more up front, and then it keeps dropping. The assumption over here is the asset is going to be more useful, it's going to generate more revenues early in life, and then it's going to taper off, so the matching should be accordingly. My journal entries are fairly straightforward. Depreciation expense debit, accumulated depreciation credit, and I have the numbers over here in the last column to plug those in over here in the journal entry. So again, to recap, in this sum of years digit method, the original cost minus estimated salvage value gives me the depreciation base. The useful life, let's for the denominator, I'll take the useful life plus 1 divide by 2. That gives me the denominator of the fraction. And I set up the fraction over here, the numerator, as at the start of the first year, what's the remaining life of the asset. So the first year I have 8 years remaining, and then it keeps dropping by 1. So the depreciation base times the fraction will give me depreciation expense. So not too difficult when we are looking at the depreciation expense calculated for full 12 months starting from the first year. Now in part B, they've asked us to redo the problem, and they've asked us to assuming that the asset was purchased on April 1st, 2017. Now this is not a difficult problem, it just involves a little more calculation. So let's see what we're going to be working with. This part all stays the same except for the date in terms of the information I'm going to bring over. None of this changes over here. So the only difference over here is the acquisition date. All the other information stays the same. So over here, these first, what I have over here, all of that stays the same. I'm just copying that over. So what I had done over here and up top over here, I'm bringing that same information over here. Now, something to note, the depreciation expense that I calculated for the first year, I said I had the full 12 months. But that's not true now, because I bought the asset on April 1st, which means I didn't have it for the first 3 months. So in this case, what I'm going to do is I'm going to split the depreciation expense, and I'm going to identify how much of it was for the first 9 months, sorry, for the first 3 months, and then for 9 months, because I used it only for 9 months. So this depreciation I split. This is 12 for 12 months. So when I split it, which is basically 9 over 12 multiplied by 16,000, I get 12,000. And then 3 over 12 multiplied by 16,000, I get 4,000. I do that for all the years. I'm doing the split, okay? Now I'm ready to calculate my depreciation expense. Okay, so I'm just again writing down the years over here, because it was all the way out over here. I just want to bring it back over here. Now, for the first year, what's my depreciation expense? I'm going to use a few colors over here to highlight this. For the first year, depreciation expense is only $12,000. For the second year, I'm going to calculate depreciation expense as the 3 months depreciation that I did not charge in the first year. It's moving over into the second year. And I'm going to add that up with 9 months from the second year to come up with depreciation expense of $14,500. That's 4,000 plus 10,500. Now for the following year, what happens? I take this number, again doing this in a different color here just to show you, and I add 9 months from the next year to arrive at the depreciation expense of 12,500. Now in the exercise, they asked us only for the first year's depreciation, which was relatively easy. If you're asked for more than 1 year's worth of depreciation expense, calculations are not that difficult. So start out with the problem assuming you had it for all 12 months. Then read this part very carefully and see, when did you actually acquire the asset? How many months did you have it in the first year? So if you had it, let's say, for 2 months, you would do the split of 10 months in 2 months. Okay, so you have to look at very carefully how many months you actually used it in the first year. Once you have this last column set up, do all your calculations for the last column. Carrying over the numbers is not going to be difficult into the journal entry. You're just plugging the numbers from the last column. Also, something else to note over here is I have an extra year. Because I used the asset only for 9 months in the first year, the last year there's 3 months worth of depreciation that's going to get calculated over here. So it's going to come down over here as well, this calculation of depreciation. The total is still going to stay the same, 72,000. That's the amount I'm depreciating. That cannot change. That number is not going to change. It's just a matter of how the depreciation expenses spread out. So if you look at the numbers you had over here, the first year you had 16,000, here you have 12,000. The second year you have 14,000, here you have 14,500. So it's just staggering a little differently over here. So slightly involved, not complicated. It's slightly involved in terms of the calculation. So once again, we need the original cost, the salvage value, that gives us the depreciation base. The acquisition date is very important. Read through that carefully. Calculating the denominator is very easy. It's n times n plus 1 divided by 2, n being the life of the asset. That gives you the denominator. And then you can set up the fractions for the entire life of the asset. Typically, in an exercise, you're not asked to calculate more than 2 or 3 years, the first 2 or 3 years worth of depreciation expense. So if you can do these calculations for 2 or 3 years, you're in good shape. You're rarely asked for anything beyond that. So this is yet another example of an accelerated depreciation method.